Greetings, growers of the world. Jordan River here, back with more Growcast After Dark. Today, we continue our series with Nick from Rooted Leaf. We take a little bit of a different approach, though. Today, we're covering the dark cycle. That's right, we're doing a deep dive into light-independent cycles, what those plants do when the lights are off. I know you're going to love today's awesome episode, but before that, shout out to AC Infinity, baby. ACinfinity.com. Code GROWCAST15 to get your savings and keep the lights on here at Growcast. We appreciate your support, and we love AC Infinity. They make the best grow tents around, extra thick poles. They've got nice, durable, thick siding. Now they have the new side ports. People have been asking for those, and AC Infinity, listen. Plus, they've got everything else you need to grow. They've got lights and pots and fans and their oscillating fans, the Cloud Ray system. Check out their humidifiers, the Cloud Forge. How nice is your humidifier? Maybe it's time to replace that. The Cloud Rays are my favorite oscillators on the market. And of course, their Cloud Line series, what they got it all started with. All those years ago when we were partners with AC Infinity, all they made were those inline fans, and they're the best in the game. So shout out to the entire AC Infinity suite. They've got everything you need to get growing, from fans to tents to lights. Code GROWCAST15 works at ACinfinity.com. You support us, and you're getting some badass, durable grow gear while you're doing it. So thank you to all you listeners using code GROWCAST15, and thank you to AC Infinity. All right, let's get into it with Nick. Thank you for listening, and enjoy the show. Hello, podcast listeners. You are now listening to Growcast. I'm your host, Jordan River, and I want to thank you for tuning into the show again today. Before we get started, I always urge you, check out everything we're doing at growcastpodcast.com. There you'll find the seeds, the membership, upcoming events and classes. We do it all for you folks. Help us out in our mission of overgrow. Tell someone about Growcast, or turn someone on to growing. That's the best thing that you can do to help us on our mission. I appreciate you being here. And as always, big thank you to the members. All right, continuing our nutrient deep dive series, this time taking a little bit of a turn. Very exciting episode today that we have planned for you on the dark cycle, light independent cycles. We're going to be talking about optimal feeding timing, optimal foliar timing. It's going to be a really good Growcast After Dark. And we have none other than Nick from Rooted Leaf with us as the guest. What's up, Nick? Thank you for being here.
Hey, Jordan. Good to see you. Or not see you, but good to be here.
Good to hear you.
That's right.
Nick, of course, running things over at rootedleaf.com, my favorite nutritional lineup. Code GROWCAST saving you 20% or more over there. So go and check it out, everybody. Rootedleaf.com. You've been killing it, Nick. Love the Growcast TV appearances you've been doing as well for the members. And this nutrient deep dive series, I have to say, Nick, it's one of the best received series we've ever done. Right up there with like breeder features and Team Growcast episodes. People like these, man. So thank you.
You're welcome. And I'm glad that your audience is well receiving to it. You know, I've interacted with a lot of people, both on Discord and people who send us messages on Instagram. So it's nice to hear positive feedback. It's nice that people take away useful information. That's really what it's about for me. And that's the most important thing, is that you can learn something by listening to these episodes that you can then, take with you into your garden, apply to your plants, and see things improve overall. So That's really, really nice. I appreciate the support of the community.
I totally agree, man. I totally agree. And the community loves you in there helping people out. So I want to continue this today, but we're moving away from like specific nutrients and specific minerals and getting into some other areas of still relating to nutrition and of course how plants grow, but we're getting into some different facets of, plant botany essentially. So today we're talking about the dark cycle. We're talking about not just light dependent reactions, but light independent reactions. So Nick, where do you want to start? Do you want to give us a little bit of a recap on photosynthesis and light dependent processes before we move on to the light independent ones?
Yeah. And I think a good way to frame it is to kind of examine like the majority of the content we've been pushing out so far about the individual nutrients and how they're metabolized revolves primarily around energy metabolism and thermodynamics. You've probably heard me talk about that quite a bit. So when we do today's episode, we'll be looking maybe at like the general schematics. You could say the general kind of overview of how energies in their various formats flow through plants. And obviously where it starts is with the energy of the light, the sunlight. It is energy. Photons are energy, and plants have evolved sophisticated mechanisms to capture that energy and then ultimately to convert it into chemical energy. So we go from light energy to chemical energy through this process of what are referred to as the light-dependent reactions. The light-independent reactions are a little bit different in the sense that they're not directly driven by light itself, but rather they depend on the chemical energy that's created when plants actually capture and convert the energy of the light. So that's the real major distinction between the two of them, that the light-dependent reactions are driven by photon energy, by light energy through the electron transport chain. And then ultimately where that light energy gets accumulated is in the form of ATP and NADPH. These are two very important molecules. They're kind of like the central currencies, if you will, for all metabolic functions.
Right. Like you covered in the phosphorus episode. Now, I want to hone in on something right off the bat, which is what you just said, which is these processes that take place when the lights are off will still take place when the lights are on. They're just not dependent on the light. However, when the plant develops a circadian rhythm, like when you have it on a cycle in a tent, it does kind of sync up with that, right? And then so during the dark period, they're going through these other processes using the energy that they accumulated from the light period. Is that a correct way of looking at it?
Generally speaking, yes, but I do want to clarify one thing, which is to say that the light dependent and the light independent processes are actually coupled together, meaning that the light dependent processes basically represent the flow of energy from the point of sunlight coming in, electrons in, chlorophyll being excited, and magnesium in particular capturing that light energy, and then funneling it down the electron transport chain, ultimately leading to the synthesis of ATP and NADPH. Those are the light-dependent reactions. The light-independent reactions will then take that ATP and NADPH and then feed that into the Calvin cycle, which is primarily what you want your plants to do.
Got it.
Having said that, the light-independent reactions are what is referred to commonly as the dark cycle, or maybe the dark reactions. That's just a little bit misleading in the sense that they still depend on the light, but rather than depending on the light directly, they depend on the chemical molecules that are generated as a result of the light dependent reactions, if that kind of makes sense. So
Yes.
You can't have one without the other. There's this third thing that happens though when the lights turn off, and that's its own thing. That has more to do with respiration in mitochondria, which we'll slowly peel this back, but maybe this is a good point for us to kind of introduce the concept to say that there's the light dependent reactions, the light independent reactions, and then something which we'll refer to as cellular respiration that happens within mitochondria as the lights actually physically turn off or as the sun sets.
Wow.
Think about it this way, like the chloroplasts themselves, their main job is to take in light energy and then funnel that light energy downward. The mitochondria, when the lights are on and when the sun is out, the main job of the mitochondria is actually to create balance in the activities of the chloroplasts. But when the sun sets and that light energy stops coming in, the function of the chloroplasts is virtually eliminated. There's no sunlight, and therefore they cannot capture any energy, which now turns the major energy production responsibilities over to the mitochondria. If you go on Google and type in what is the function of the mitochondria, you might see something along the lines of, mitochondria are the powerhouses of the cells.
Yeah,
they
baby.
produce the energy in a cell. Well, that may be true, but it's only true in plants, in cannabis plants specifically, when the lights are off and when the sun has set, because that's where the mitochondria take over the role of energy production. Whereas during the day, the amount of energy that's coming in feeds chloroplasts, and the activities of the mitochondria are there to just kind of create checks and balances to ensure the appropriate flow of energy through the chloroplasts without over-reduction of any particular compartments within the plant and without allowing for too much oxidative stress to build.
Interesting. So the mitochondria playing a big role in balancing that energy. Okay, so you gave a good recap on the photosynthetic cycle itself and like what's going on as it creates and stores that energy. You mentioned the Calvin cycle. Can we go there? What is the Calvin cycle? Does it start when the lights go off if you are on a timed system like that? And what's happening?
Yeah, so the Calvin cycle, Calvin-Benson cycle, a lot of people are familiar with this enzyme called rubisco. And in fact, we've kind of taken a look at it. Rubisco is the enzyme that actually takes CO2 out of the air. And, that is a process that is powered by light energy. So ultimately, we have these light-dependent reactions creating ATP and NADPH. That ATP and NADPH is then fed into the Calvin cycle. And within the Calvin cycle, you've got this enzyme called rubisco, which catalyzes the conversion of CO2 into a phosphate sugar, basically. It's the first dedicated step, but it actually draws this cycle specifically, not Rubisco as an enzyme, but the cycle at large creates a draw for the ATP and the NADPH. So these technically fit underneath the light independent reactions that we had just talked about. But again, keep in mind that in order for the chemical currency to be generated depends on the activities of the light dependent reactions and the electron transport chain specifically. So ultimately, the purpose is the conversion of light energy into chemical energy and then the utilization of that chemical energy. The majority of that chemical energy is going to be used within that Calvin-Benson cycle, which again takes CO2 out of the air, creates sugars for the plant. Part of the cycle is that it returns a portion of the substrate back to Rubisco. So it's a good way to continue the flow of carbon substrates without actually depleting the substrates that are necessary for carbon fixation. That's why these things are referred to as cycles, because their operation feeds substrates to the next step in the process until you return to the origin point where you have the substrate that's been fully regenerated and the plants can act on that substrate again and they continue to move it forward through. And there's branches, that kind of fork off these cycles, and these branches are what create different substrates, perhaps for different enzymes to act on.
This is so fascinating. So it's essentially this conversion and reduction process into sugars, right? Like you said, right? Glucose. What happens to those sugars?
So the sugars, for all intents and purposes, the sugars themselves become building blocks for pretty much all major pathways within plants. But there's something interesting about, I think we've actually talked about this before, malate valves and citrate valves. So chloroplasts have these membranes and they're fairly impermeable. So when you're dealing with ATP and NADPH, those molecules are a little bit too large to pass through the membrane. You don't want to over-energize certain compartments within the plant cells, because keep in mind, it's just like you have this light energy, this electron energy coming into the chloroplasts. The function of a lot of these enzymes and the machinery within the chloroplasts is actually to allow for the continual flow of that power. So yes, it gets converted and trapped in the chloroplasts, but ultimately it's destined to be exported from the chloroplast, and then it gets fed into the cytosol, and then it gets fed into the mitochondria. And this energy kind of disperses across the entire plant. It originates from the chloroplast and flows outward from there. The point I'm trying to make here is that optimal operation of chloroplasts and the electron transport chain and the Calvin cycle and all of these wonderful things like carbon fixation depend on this flow of energy outward. So we have these malate valves within chloroplasts that allow for stored forms of energy, particularly malate, to be exported from chloroplasts where they're generated, because the ATP and NADPH cannot. They continue to get built up in the chloroplasts, but the way that they move out is in actually the slightly different form. Malates will enter the cytosol and they'll enter the mitochondria and continue to be metabolized, because those represent the stored pools of energy and the stored forms of energy. It's also interesting to note that when we're looking at chloroplasts, the chloroplasts and the mitochondria, they both create energy for the plants. They both create ATP and they both create NADPH. The chloroplasts do it through photophosphorylation, obviously photo implying sunlight, phosphorylation implying the generation of ATP. Mitochondria do it through oxidative phosphorylation, not photophosphorylation. So you have these two distinct compartments within the cells that are both capable of producing energy, and they do it in two slightly different ways. The activities of them are actually tightly coordinated with the activities of the other. So like I said, here is one example. When the lights are on and the sun is out, the plants are actively synthesizing compounds in the chloroplast because they're capturing that light energy and they're converting that light energy, and then that converted form effectively gets moved out and transported. Glucose and sugars certainly are one example of that stored energy that can be worked out into the cytosol. Maybe there's a couple of enzymatic steps before that happens, but certainly the flow of substrates continues outward from the chloroplast. So you find they almost leak out the good stuff into the cytosol surrounding them and also into the mitochondria, which actually feeds them, because the mitochondria will actually break down sugars that are produced by the chloroplast, by the activities of the chloroplasts.
So this is a CO2 reduction process. What happens when we supplement CO2, and talk about supplementing CO2 in the dark period? What are the implications of that?
And that's where kind of like the light dependent and the light independent reactions, it makes sense for us to pay attention to them because they're not necessarily disconnected or disjoined. They're actually very tightly regulated and coupled with each other in the sense that those light independent reactions actually still depend on the light. We've just drawn a line in the process flow and said, okay, here's two distinct phases of the process flow.
Mm-hmm.
One phase will convert light energy into chemical energy. Let's just call that its own phase. That's called light dependent reactions. And then light independent reactions, those take the energy, the chemical energy, and then utilize that chemical energy. So if you don't have the light energy coming in to produce that ATP and NADPH, those light independent reactions tend to not necessarily be powered.
It's all dependent on the photons.
Yeah, for that particular example, yes. But now this is where we can kind of talk a little bit about the roles that mitochondria play, because as I mentioned earlier, mitochondria can also produce ATP and NADPH. And a majority of that function is actually increased and elevated as the sun sets and as the lights turn off. The plants kind of go into darkness and the activity of the chloroplasts decreases, but the mitochondria are still active. The mitochondria are still capable of producing energy, and they're capable of producing substrates like those which can be derived from the Krebs cycle or the tricarboxylic acid cycle, TCA for short. And those substrates that are produced as a result of respiration in the mitochondria, those can actually be substrates for the biosynthesis of secondary metabolites. You see evidence of this in some plants that release their wonderful aromatics at nighttime. There's a whole bunch of species of plants out there. Night blooming jasmine, angel's trumpet. There's so many different species of flowers that release a very, very potent smell at nighttime. And it's evidence that there's metabolic activity occurring even as the sun sets. Are you familiar with some of these plants?
Yeah,
have you ever heard of that?
I have heard of those. And that makes sense. When I was down in the coffee farms, they would say that they were harvesting at night. And sometimes they would even time it with the full moon. And it was an ancient practice that said something about the sweetness and the compounds that the coffee cherry was producing. It's kind of similar to what you're saying as far as releasing these scents at night, right?
Yeah. And it's a good way for us to kind of look at maybe some of the lesser known or lesser discussed aspects of plant metabolism, which is to say that even though, the lights turned off for the sunset, that the plants are actually still active. They're not photosynthetically active, but they're still energetically active.
Mm-hmm. The motor's still running. It's not in high gear or whatever, but the motor's still idling.
Yeah. And it's not necessarily an idle. I mean, it's, there is this burning of sugars that have been built up throughout the day. So, as a result of photosynthesis, the plants will build up stored pools of energy. This is sort of the byproduct of the light dependent reactions. There's a continual buildup of chemical currency that is saved and stored for use at a later period of time.
Mm-hmm.
That energy is not going to be utilized by the chloroplast. It's produced by the chloroplast, but it ultimately gets funneled over to the mitochondria in some, form or other. When the lights are on and the chloroplasts have this flow of energy, chemical energy, outward into the mitochondria, it's done through these malate valves, which progressively open and close depending on the intensity of the activities of the chloroplast. So when the sun is, very bright, the light intensity is very high. The activity of the malate valve will be most open, I guess you could say. It's going to allow for the greatest pool of substrates to be transferred out of the chloroplasts and towards the mitochondria. As the sun sets or the light intensity decreases, those malate valves progressively begin to close because if there's less light energy coming in, there's less generation of ATP and NADPH, which means that there's less flow of malate to mitochondria. What ends up happening is that the sugars which are produced throughout the day and stored up in various compartments, maybe it's the vacuoles, maybe it's somewhere in the cytosol, or, maybe it's just outside of the mitochondria. There's these stored pools of chemical energy that will get utilized by the mitochondria through cellular respiration. During the day, precursors of malate will get broken down and precursors will be fed into the Krebs cycle. Whereas during the nighttime for cellular respiration, instead of malate being the primary efflux from the chloroplasts, you have instead glucose feeding that pathway through glycolysis. Plants also break sugars down, just like humans break sugars down. Every time that we breathe in air, we're getting oxygen into our blood, and that oxygen powers this process of oxidative phosphorylation that occurs inside of our mitochondria. And the same thing is actually true of plants. They have the exact same tools and the exact same mechanisms to produce ATP and NADPH in the absence of light.
The same energy currency that we use in our bodies. That's a really good point and very interesting.
Correct. Yeah.
So talk to me about how this affects my gardening schedule. Like when you look at these processes, what changes from the perspective of a home grower? I'm talking about things like I mentioned before, like harvest timing. Right now, I just kind of tell people to follow their nose when it comes to harvest timing. I like to harvest it when the plant is stinkiest. And I'm really hesitant to even say this because it's so unscientific and it's just my experience. But it seems to me like a lot of the time when I'm doing that style, it seems like it's really stinkiest towards the end of the light cycle or just after the light cycle has ended in the night is when I'll go in there and smell it and be like, okay, I think this is now again, that could just be totally subjective. It's a small sample size, but do these cycles change the way that we should be thinking about things like harvest as home growers, harvest timing?
Yeah, that's a good question. I think it could just depend ultimately on personal preference. That's maybe what it comes down to. As far as like the metabolic fluxes and stuff that happens within the plants, it's such a complex thing. You have circadian rhythms that are involved. You've got, I think we even touched on some of this stuff when we were doing our episode on calcium and also the one we did on magnesium and certainly on potassium, where these elements actually play critical roles in signal transduction. So at nighttime, for example, as the stomata close, the actual physical closing of the stomata is a function that's driven primarily by potassium and calcium. So here's this instance of circadian event occurring where the plants are actually quote unquote going to sleep, right? The stomata are closing.
Mm-hmm.
Transpiration will kind of come to a grinding halt. Chloroplasts will come to a grinding halt. You have these major changes occurring within the very central machineries of what defines a plant. All this photosynthetic gear and machinery inside of the chloroplasts is ultimately what defines a plant. And we have this period of activity where that whole process begins to shut itself down. This is a major change that happens in plants. And there's minerals that are involved. There's hormones that are involved. There's all kinds of different enzymes that get upregulated and downregulated. So what happens at nighttime is quite complex, to say the least. There's still metabolic activities happening. There's cellular repair that's occurring. There's DNA repair. There's all kinds of maintenance and upkeeping stuff that's being done. There's still compounds being loaded into the phloem and being transported down back to the roots because, during the day when the light is on and the sun is out, the stomata are open and that creates a draw on the roots to move water up from the xylem. So you have xylem basically as a one-way highway, and it takes water and dissolved minerals from the roots up to the leaves and then out through the process of transpiration.
So when it comes to harvest, though, let me ask you this, like terpene production, is that still thriving at this time? Or B, is it so negligible at that point? This plant has been flowering now for like 8 to 11 weeks and it's produced a lot and it's producing more and it's gassing off some, right? Like, give me your honest opinion. Is it a good idea to be harvesting at night or is it basically negligible at that point?
I don't think it's going to make that big of a difference, honestly.
Right.
It may just come down to personal preference. I've heard some people like to harvest just before the sunrise, early in the morning. I think that works pretty well too, but certainly once the lights turn off, it could also be a function of how wet are your plants. Maybe that's one of the things you want to consider too, because if you know that you're going to wash that plant and it's just destined for hash, you might as well just, completely waterlog it and overwater it because you want that plant to swell up as much as possible. You want those trichome heads to actually push and protrude off the surface of the leaf. And the best way to do that is to just shove a bunch of water inside of that plant. I mean, hey, you're going to harvest it and throw it in a bunch of water anyways and ice and then just beat it up and stir it around. So why not just get the plants to be loaded up with water from the inside out? This will cause the trichomes to push a little further out on the leaf surface. So when it comes time to freeze them, they'll be easier to knock off because they protrude a little bit further. So this could be one of the things that you do just kind of based on that. If you're looking for, aromatics and the difference in how loud something is, that could be a strain specific thing as well, where some strains may just be a little bit more aromatic at nighttime and others may kind of get really, really skunky and really gassy and really stinky in the early hours of the morning.
Yeah, true. Good call. And then on the flip side, if you're going for flower, you probably don't want to do a watering right before harvest because then you throw it in your 60-60 dry and it takes way too long and there's a risk of mold and things like that. So
where the product is destined going to be dependent on how and when you harvest. All really good stuff, Nick. This is fucking good. It's good advice for the listener.
The other thing to consider too is like along those lines too, if you find that the soil is getting really, really dry towards the end of the day and you're thinking to yourself, well, do I want to water it once again in the morning or do I want to harvest? If you're kind of making one of those decisions, probably best to just harvest it at nighttime when the soil is really dry. And this may be a minor point altogether, but as a byproduct of the activities of mitochondria at nighttime, because the stomata are closed, it kind of prevents, and it doesn't really prevent because they're not fully closed. It's not like plants are a perfectly sealed environment at nighttime. The stomata do have they're semi-permeable. Plants don't vacuum seal themselves from the inside out during nighttime.
They just kind of kink the hose, right?
Exactly. And what ends up happening is because the mitochondria are still active, they in fact produce certain byproducts. One of those byproducts is CO2, and another one of those byproducts is H2O. So this may be negligible, but just as a point of pointing out some of the mechanics of what's going on here, at nighttime, plants will become just a little bit more wet internally because the mitochondria produce CO2 and H2O as a byproduct of their respiration. So I'm not saying this is going to make a huge difference. You're not going to notice a 5% difference in moisture concentration.
That's fascinating, though.
Yeah, just in terms of the mechanics of what's going on, just want to point that out. So it may be a good idea with some cultivars to harvest them when they're really, really dry. At that, in that kind of a context, it would make sense to dry shortly after to harvest the plant right after the lights turn off, because that's when they're going to be the most dry, I guess you could say, and have the most sugars overall before their sugars get entered into the mitochondria and get broken down.
Okay, I like that.
But then again, the breakdown of their sugars in the mitochondria, yes, it releases CO2, yes, it releases H2O, but it also creates substrates and building blocks for terpenes and cannabinoids, which your plants may be able to produce at nighttime. And if you've ever, left your grow room at night, the plants maybe have a smell, but it's not as strong as it is in the morning just before the lights turn on. If you've noticed that with your strain, then it could be a good indication that they're pretty active at nighttime.
So what about watering? My understanding is, I think on a member episode, you said watering at lights on is not a bad idea, right? That's probably optimal.
Yeah, and I think it kind of depends. A lot of people will do crop steering, and so they'll do things like maybe water an hour into the day or an hour and a half into the day during like the flower stage. I think plants are just ultimately trying to create and maintain balance. That's what they're really, really good at doing. They're wonderful at creating equilibrium.
Sure.
So what you want to do is just get into a habit and a rhythm where your plants are just performing optimally. You may have some weird, plants have very weird personalities. The more you get to know these plants, the more you realize like they're not just, I know we're looking at the mechanics, we're kind of looking at this stuff in a very robotic way, but there's also this like totally immeasurable layer of what goes on inside of the plants. And it's impossible to measure it objectively. It's more easy for us to talk about it, to say these plants are just quirky. They've got nuances, the wedding cake versus the, Skittles and ice cream cake and all this stuff. They're going to have slightly different tendencies as far as how much water they want versus how much nutrition they want versus how much calcium or how much phosphorus. All this stuff kind of factors in, even the timing of the watering. So I think it's important for most strains because it's mechanically kind of fits in. If you can get strains used to being watered earlier in the morning, maybe within the first hour of the day, I think you're going to get better productivity overall. That's just generally speaking true, but not specifically.
Oh man, I love that take. I really love that take. That's so true. Like you said, the immeasurable nuances. So what we end up doing is like personifying them, which I think is all my favorite growers personify their plants, by the way. That's like something I've noticed amongst like some of the growers that I respect the most. Mm-hmm. I like that, dude. That's a very interesting and accurate take.
Yeah, there's an art and a science to these plants too. We're taking the angle of a science forward approach, but I also want to acknowledge that there's so much art associated with it as far as like, we're just never going to be able to quantify it. You can't measure these things in terms of ATP and NADPH. You just got to say, that's a fucking weird plant. It grows like a monster. It's got a weird personality.
Yeah, totally. It grows like a monster, acts like a monster sometimes. That's so true. Yeah. I really like that take
thirsty, a lot. She takes a lot of calcium.
Hangry.
That type of stuff.
Yeah, hangry.
Yeah.
Rootedleaf.com. Go and get the no need to pH nutrients, the best around. 42% off. That's right. Code GROWCAST gets you 42% off for a limited time. This is the Black Friday sale for Rooted Leaf, but guess what? Code GROWCAST, you're going to get that discount early, and you're also going to get it extended. It's code GROWCAST for 42% off. Usually it's 20% off. Right now you can grab your Rooted Leaf nutrients, which are the best, for 42% off. No need to pH Rooted Leaf nutrients. Just hit them into some filtered water and let her rip. They're packed with microbes. They're made from plant extracts. Your worms will love them. Your soil will love it. All that biology is going to love adding that sweet, sweet Rooted Leaf on top. Heavy carbon-based nutrients. You don't want to miss out. If you're not completely satisfied with your nutritional regimen, or if you're in living soil and you just want a little extra boost, rootedleaf.com. Use code GROWCAST. It's 42% off right now. It's usually 20% off. You can go get a great deal. Get the starter pack. Get the CalMag Fuel, the Solar Rain. If you've been meaning to try Rooted Leaf, now is the time. Code GROWCAST for 42% off Rooted Leaf Nutrients, my favorite nutritional delivery system. You won't regret it. Rootedleaf.com. Go and grab them. You know, Nick works really hard on these formulations, and they really do amazingly with the cannabis plant. So rootedleaf.com, code GROWCAST, 42% off. Go grab it, folks. Thank you, Nick. Thank you, Rooted Leaf. And enjoy those sweet, sweet nutrients. So before we get off the Calvin cycle, I was just looking it up, you know, giving a quick history research on it. And I realized that it was discovered just after World War II. Like just after World War II, 1947, as a result of some radiation laboratory fund from Berkeley. And it's got a really cool history and two dudes that it was named after, Melvin, Calvin, and Benson. But it was just funny, Nick, because I could see you in this time period. You would have been doing this. Like if you were around in 1947, you would have been on this team, I feel like. You ever get that? It's just really cool that they discovered it when they did. And I feel like you could be part of that, part of that time.
Yeah. And to kind of, piggyback on top of that, I think if I understand correctly, there's a third guy involved, right? With the Calvin Benson cycle. I forget the guy's name, but he's someone who's often forgotten. And it's a little bit ironic that I'm saying I forgot his name.
Bassham. Yeah, but you know what? With a name like Bassham, you can't, I'm sure it's like Bosham or something like that. James Bassham was the third guy. You got a name like the Bassham cycle. Actually, that does sound pretty delicious. Sounds pretty tantalizing.
Yeah. And, as an extension of that, the Calvin Benson cycle, they were researching it in like the 40s and the 50s. And prior to that, I think, in the mid to late 1800s, people had suggested formaldehyde was actually the primary thing that was produced by plants as a result of CO2 fixation.
Whoa.
So that's what they thought. But then it was proven that Rubisco actually catalyzes a different process altogether that creates different kinds of carbon-containing compounds. It's not
formaldehyde. That's nuts. That's really, really cool. Yeah, I just thought that was fascinating, like seeing how the nuclear age kind of played into that. The war ended in 45. In 47, we discovered this guy. So that's how long, less than 100 years we've known about this. That's pretty fucking crazy if you think about that. So yeah, very interesting. Okay, so what about this other cycle that I believe is a late independent one? I don't want to sound stupid here. It also sounds delicious. The Krebs cycle. What is the Krebs cycle?
Yes. So the Calvin cycle occurs within the chloroplasts, and that is basically the process by which CO2 is taken out of the air and then converted in the actual Calvin cycle into those sugars that we were talking about. And those sugars are kind of exported from there, and there's this huge fork and a branch, a splitting effect that occurs where you've got sugars feeding into a variety of different pathways and different, serving as different substrates. Certainly a portion of the sugars that are produced through the Calvin cycle are recycled back to Rubisco so that there is a terminal acceptor for the CO2 that's being taken out of the air. So the nice thing about the Calvin cycle, and the reason it's a cycle, is because it can kind of power itself. It will create the sugars and then replenish the sugars that were utilized in the process, that were removed from that step in the process.
And so, when I asked earlier where they went, the answer is everywhere, including back into the cycle.
Yeah. And primarily with the chloroplasts, the energy gets sent out in the form of malate residues and malic acid in particular. So sometimes that malic acid as an organic acid will actually complex with potassium to create a charge balance within the cells. We talked about it. Yeah. We talked about this in the episode on potassium, where I mentioned potassium is like the balancing element. It creates balance with some of the negatively charged compounds like the organic acids that are produced as a byproduct of photosynthesis. And specifically, it's that malic acid. Potassium malate is probably one of the most highly accumulated forms of potassium in plants, because again, through this photosynthesis process, you've got these negatively charged organic acids that are permeable across the chloroplasts. Then they move through a valve that is opened or closed depending on the activity and intensity of the sun. And then that flow of energy in the form of malate can be used to do things like complex that potassium, or it can get transferred into the mitochondria and enter the Krebs cycle.
Oh,
So
wow.
we've gone from the Calvin cycle into the Krebs cycle. The Krebs cycle is also known as the tricarboxylic acid cycle. Tri meaning 3, carboxylic obviously is what people refer to as organic acids, but it's an amalgamation of 2 words. One is the carbonyl motif in chemistry, and the other is the hydroxyl functional group. So you have this carboxylic acid, tricarboxylic acid pathway. So the cycle, the TCA cycle, the Krebs cycle, kind of like the Calvin cycle, it does a really good job of replenishing its own substrates, and it's fed primarily during the, when the chloroplasts are active and they're photosynthesizing. The Calvin cycle is primarily fed by the byproducts of the Calvin cycle. So as one operates, the other feeds off of that.
Mhm.
And then what ends up happening is it returns substrates back into the cytosol, and some of these substrates are important compounds like organic acids. 2-oxoglutarate is a very important organic acid because it's the very backbone of amino acid biosynthesis. This is the molecule that is created through photosynthesis in the mitochondria and exported back out into the cytosol, where it can be used to create amino acids.
Oh,
Very, very
interesting.
important stuff there.
It's also known as the citric acid cycle, right? That's the you're talking about.
Yes.
Okay, interesting.
Yes. Citric acid cycle is very important. Like I said, it does produce ATP and NADPH. The mitochondria will produce ATP and NADPH, and through the citric acid cycle, it will also produce precursors for amino acids like that 2-oxoglutarate that I mentioned. This is really important to keep in mind because you have this reduction power that's being generated in the chloroplasts. They can be funneled off towards the Calvin cycle for CO2 assimilation, or there's actually sometimes competition in the chloroplast. Sometimes instead of that ATP and NADPH being fed to the Calvin cycle, it may actually go somewhere else. And one of those other spots is an enzyme called nitrate reductase. And nitrate reductase can utilize the reduction power in a sort of a competitive way to reduce nitrates into their ammoniacal forms. But that reduction is useless because unless you have an organic acid, specifically 2-oxoglutarate, already present, then you can't actually make an amino acid. And plants don't like to build up stores of free ammonia. Ammoniacal forms of nitrogen tend to create acidification. They tend to acidify compartments of the cells that actually don't need to be acidified. Their optimum operation depends on mild alkalinity, maybe slight acidity in some cases, but where you want that acidic charge to build up is actually on the inside of the chloroplasts, where you've got this synthesis of ATP and NADPH going on. But yeah, so the Krebs cycle produces these organic acids, feeds them back into itself. And like I said, during the day when the activities of the chloroplasts are quite high, that malate is feeding that. But at nighttime, when the chloroplasts are inactive, they're no longer operational, the stored up sugars get broken down. And then as they get broken down, the breakdown products, pyruvic acid in particular, will then enter the Krebs cycle in that pathway. And that's where the mitochondria continue to respire. They go through cellular respiration, literally in the exact same way that when you breathe in, your lungs accept that oxygen, and then that gets dissolved into your blood, and so on and so forth until finally it hits the electron transport chain in the mitochondria.
Mm-hmm.
That's oxidative phosphorylation. You're creating energy, ATP and NADPH, as a result of this cellular respiration. Plants do the exact same thing.
So feeding into each other, like you mentioned before, the 2 cycles at play. Okay, I got it. Hans Krebs, by the way, for those who were wondering. So again, let's tie this back to what we could do different in our garden. You talked a lot about the stomata. I would like to know about things like foliar timing. We always spray with our plants with the lights off, right? But that's usually because people don't want to have any sort of like phototoxicity or anything like that. If I'm going to deliver a nutritional delivery, I can do it under my LED lights. I'm not under HIDs anymore. Mm-hmm. I'm just wondering, what's the deal with plants taking up nutrition through the stomata and spraying with the lights on versus spraying with the lights off?
That is a very complex topic. It's a great question. And I think ultimately the answer to that question revolves around what is it that you're spraying on the plants. If you're trying to deliver soluble forms of nutrition, you don't want that to hang out on the outer leaf surface. But if you're trying to deliver a pesticide or a fungicide or something like that, maybe you do want that compound to actually sit on the outside of the leaf. Maybe you don't want the plant to absorb it. And so in that case, where you're trying to create a protective barrier on the outermost layers of the plants, it would make sense to apply that compound when the lights are off and the stomata are closed, because then the absorption of that will be significantly reduced. However, if you want to deliver soluble nutrition to the plants, maybe a better approach would be to spray when the lights are on, because then the stomata are open and they can allow for a major influx of water.
Wow, I didn't think about that. So if you're spraying horticultural oils, the last thing you would want to do is spray when the stomata is open, because that's one of the downside of that pest spray is that it clogs that stomata. So wait until they're closed. You're keeping it on the, quote, outer surface. That's a really good distinction, man.
Yeah, and it's also important to note that a lot of these essential oils, if they get worked inside of the plant, they can actually do a lot of damage.
Sure.
Because there's membranes, for example, these phospholipid membranes. You don't want to dissolve those membranes because they effectively create barriers to separate what's inside of this, whether it's a compartment in the organelle or a particular enzymatic reaction or whatever it is. Membranes are very important, and the integrity of phospholipid membranes is very important to maintain. So it's important to understand that. And in fact, actually, while we're on this topic, I just want to mention real quick that these membrane, when we talked about the electron transport chain, a lot of the photosynthetic machinery is actually membrane bound, meaning it's embedded in an actual membrane, where on one side of the membrane, you have a distinct environment. And then on the other side of the membrane, you have a distinctly different environment overall. And that membrane itself is where the electron transport chain is doing its thing. This allows for the buildup of protons and ATP synthase constituents on one side of the membrane. And then when that ATP is formed, it actually gets pushed out and enters the other side of that membrane. So in this case, I'm talking about the stroma versus the lumen inside of the thylakoids.
Oh boy. Okay. 3 more episodes coming up.
Yeah. What was your question before? Sorry, we went a little off topic there.
That was good. That was good stuff, man. No, you were following up on the entry of essential oils into the stomata. Really beneficial compounds, but I mean, just like us, you don't want to swallow those fucking things. So that's a really good distinction, is what you're spraying and whether or not the stomata are open or closed, and whether or not that's a good or bad idea.
Correct. Yeah. And in some cases too, with organic acids, those can be actually very beneficial. The mechanism by which organic acids can functionally deliver nutrients to plants is actually quite complex, because there's so many different layers and components of the outermost layers of a plant cell. You've got the cell wall, for example, and even within the cell wall, there's distinct layers of that cell wall which contain distinct molecules. Maybe some of them are amino acid residues like the hydroxyproline-rich glycoproteins. Maybe some of them are actual calcium ions that are cross-linked with pectic acid residues. And certainly you've got borate esters that are present, linking everything together. So this is a very, very complex landscape of stuff that's happening. As it turns out, when you have certain types of compounds like organic acids in a foliar spray, it interacts with the constituents of the cell wall in such a way that promotes the movement of those minerals inside of the cell. It's almost like you have this zipping, you have an unzipping effect, so to speak, where the organic acids themselves might interact with the cell walls in such a way to loosen the cell wall constituents and to allow them to kind of unzip, deliver the mineral nutrition, and then zip back up behind them. So you have this like opening and closing of the cell wall, but it's done in kind of a more rigorous and complex way than I'm just describing it. But yeah, that's effectively
one
of the mechanisms.
Is that something that we're missing from a lot of our like basic nitrogen bullcrap foliar? Like I imagine that's probably not in a lot of products, complex acids.
Yeah, if you're doing foliar sprays of calcium nitrate versus foliar sprays of organic acid versions of calcium, or even magnesium or potassium, let's take any one of those minerals, the nitrate forms of those minerals versus the organic acid forms, where they're the fulvic acid fractions, which are fulvates, or the citrates or the acetates. It's fundamentally different chemistry entirely. They'll still be absorbed, but even the chemical partitioning and the processing and the funneling of this compound down a variety of different pathways, all that stuff is fundamentally different. And when we're looking specifically at the interactions that some of these compounds can have with cell wall constituents, it's really important to keep in mind that when you're doing the organic acid foliar sprays, those organic acids, yes, they're the chelating agents, but they're also the precursors for the cell walls themselves, which you are literally applying directly to the outside of the cell wall.
Mhm.
So in terms of how spatially close is a precursor to the final metabolite, it's almost inseparable. You're actually pushing building blocks for cell walls through the cell walls themselves. So it makes sense why when plants receive organic acid forms of calcium, magnesium, and potassium, there's different enzymes that are upregulated with the metabolism of those chelated forms, because again, it's the mineral, yes, is important, but it's also the chelating agent itself. It's the carrying molecule.
Oh yeah.
The carrying molecules can be repurposed. They can be reconverted. If you're talking about magnesium citrate, like we have inside of our Solarain, well, we just talked about the citric acid cycle. So wouldn't it make sense to supply a precursor in the form of citric acid into the plants, maybe so that they can use it in the citric acid cycle?
That is
And yes,
amazing.
it is actually quite that straightforward and simple. There have actually been a lot of studies that have shown that the DNA of plants responds to exogenous applications of citric acid, meaning if you take citric acid that's not produced inside of the plants, that's not produced as a result of the activities of the mitochondria, if you just do a foliar spray of citric acid, the plants have a noticeable response right down to the DNA expression. The nucleus, the very innermost compartment of a plant where all the DNA exists, starts to get stimulated as a result of this application of citric acid. So there's this
Whoa.
message that gets sent to the plant saying, hey, there's free citric acid coming in. And now all of a sudden that citric acid, enzymes that utilize citric acid or its derivatives can now start becoming a little bit more functional and more active because there's more substrate for them to act on. And therefore they can do more work. And if they have the ability to do more work, they will do more work. And so in some cases, to kind of wrap this point up, in some cases, I have seen good results with people doing foliar sprays of Solarain at nighttime just before the lights turn off, maybe 5, 10, 15 minutes before the lights turn off. Do an application of Solarain because it's very heavy in organic acids, particularly citric acid and fulvic acid and acetic acid. We've got all those chelated forms of magnesium in there. And at nighttime, the mitochondria will definitely 100% utilize that citric acid so that by the time you walk into the garden the next morning, you'll see the plants have done a lot of work overnight. There's no other way to describe it. But yeah, they were busy, they were active, they were doing work overnight. I walked in the garden this morning and they look like totally different plants.
Literally what I was going to say is that the reason why Solarain works so well? I've been using it on my outdoor garden. Oh my God, man. I know that your foliar program contains more than just Solarain when it comes to your cannabis foliar program, but spraying that Solarain on my outdoor garden was like magic sauce. It was fucking crazy. The tomatoes went nuts, which by the way, I shot that video. I fixed the blossom end rot with your CalMag fuel, completely reversed it.
Nice.
And closed off the fruit formations. And in the cases of the ones that were just barely damaged, they even like just calloused over and it turned into kind of a blemish. Like it reversed the blossom end rot. I just can't say enough good things, man. Like the product really, really works. And like I said, I know your foliar regimen, there's multiple you can spray, but the Solarain is a standout. Like if you're just going to grab one bottle, Solarain for sure. Always code GROWCAST, of course.
Yeah, and Solarain is our flagship product for a reason. I think the formulation itself, because it was specifically engineered for the way that plants absorb nutrients through the leaf surface, it works remarkably well. I mean, you will see a difference within 5 or 10 minutes. You just pick a plant that doesn't look too healthy, maybe one that's a little bit yellow and run to the litter, spray it and come back in 20 minutes, or spray it before the lights turn off, come back, the following morning and just try to take a measurement of the plant, see how it's doing. There are major benefits associated with that. And it's specifically, again, because we have these organic acid precursors that actually serve as fuel for mitochondria. So during the nighttime, if you want your plants to be active, if you want them to do work and keep making building blocks for terpenes and for cannabinoids, then one of the best strategies to adopt is to introduce the precursors through the leaf surface because it's immediately available. They take it up within a matter of a couple minutes. And the benefits of that last actually for a very long time. There's so much free organic acid substrate that's delivered to them through Solarain that really the plant's activity stays elevated for at least 48 hours. I'm sure this is something you've seen with the outdoor plants as well. It's not like they just have a pronounced response in a couple of hours and then that response dips. On the flip side, they have a pronounced response for at least 48 hours. In some cases, I've seen, the response for as long as 72 hours where the plants continue, once they've accessed that pool of available energy in the form of the citrates and the acetates and the fulvates, they can burn that very slowly over the course of up to 3 days. So the plants can actually create more of everything that they want to create, whether it's terpenes or cannabinoids or pigments or even amino acids. If you've overloaded your plants with too much nitrate, the best thing to do is to spray some solar rain, because there's reduction power built in that the mitochondria will tap into, and they will fuel the process of nitrate reduction so your plants don't become overly taxed. They won't get burned. They won't get depleted of their energy, and they won't show signs of nitrate toxicity if you spray them with solar rain. And again, it's just because that reduction power is afforded to them by the metabolism of those organic acids that you see right there on the label.
That is awesome, man. So awesome. I encourage you to try it, listener. I love it. Like I said, code GrowCast at rootedleaf.com. But before we wrap up the subject of foliar, what else are we missing when we take a look at how average home growers foliar spray? Is there anything that you can think of that like we could improve our technique, whether it's timing or, like you said, certain things being missing from a lot of products, or even down to things like water temperature or pH? Is there anything you want to speak on, like optimal foliar technique?
Yeah, it just depends, I think, on what it is your plants are lacking. In a high desert, if it's a really dry environment and it's really hot and you constantly struggle to keep the humidity up in your room, what I would say is it's a really good idea to do foliar sprays during periods of when the light is on, because that's when you need to add some more moisture back into the air and get that VPD back in check. The other thing that you're going to do is, by doing foliar sprays, even if it's light amounts of our products, even if you're using it at half the dose every single day, it's going to give the plants a nice bump in their ability to transpire more efficiently. So they'll naturally push more water out and try to raise the humidity of that room naturally themselves. And as a direct byproduct or consequence of that, it means they drink water more rapidly too. So again, if you're running into the issue of that, the humidity in the room is constantly too low and you struggle to keep it wet enough, take advantage of those foliar sprays during the day. You don't have to spray a whole lot, but if you can spray once every day or even twice, a light little mist every day, your plants will have a noticeable benefit associated with that. Same thing would be true of nighttime. You can do a very, very light application of foliar sprays like solar rain at nighttime. Don't drench the plants, don't douse them, but just a little bit to kind of keep the humidity on the outermost layers up a little bit higher. It's okay if the air itself is dry, as long as there's a little bit of moisture that's been accumulated on the outside of the leaf. Plants do much better as a result of that.
That's fascinating.
Alternatively, you can do foliar sprays either at nighttime or during the day. In reality, it's probably best to do it as the machinery within the plants starts to switch, because as I mentioned earlier, when you shift from chloroplasts being the major sites of energy production to the mitochondria, there's all these changes that happen and take place, and plants are trying to create an equilibrium between the activities of the two. In other words, mitochondria support chloroplasts during the day, and then mitochondria are free to do their own thing at nighttime. And so it's really the transition of the sun rising and the sun setting, or the lights turning on and the lights turning off, that you get these fluxes of metabolic activity that you want to try to catch if you can. So spray 10, 15, 20 minutes, either before or after the lights turn on or off. If you're somewhere in that nexus, maybe half an hour plus or minus, you'll get good responses. Whereas if you're like 4 hours into the dark cycle, or if you're 8 hours into the day, you may not see as massive of a response. Unless, of course, your air is really dry, like I mentioned earlier. If you're dealing with humidity as the major limiting obstacle, then by all means, spray 8 hours into the day. That's a good idea. Keep that humidity up and your plants will respond better.
I love those tips, man. That's great. That is exactly what I was looking for. Fantastic episode, man. I love the breakdown of the Calvin cycle, the Krebs cycle, how they all relate and how they relate to photosynthesis. The foliar talk was absolutely awesome. Optimal watering times, harvest times, we went over it all. Any final updates? Any trips you're going to be taking? Any big sales coming up? Things like that.
Yeah, and actually, maybe we should have done this towards the beginning of the episode, but we're going to be having a sale for Black Friday, and that GrowCast coupon is not going to give people 20% off. It's going to give them 42% off. We do this sale 3 times a year. We do one on 4/20, 7/10, and then right around the holidays. So what we're going to do for the GrowCast community is extend that sale overall, so you guys will have at least 1 full week, maybe 2 full weeks of additional sale time. So if you're currently running through our products and you may not need more immediately, just know that that coupon code is going to be active for this community specifically for a lot longer than it is with the standard coupon
Oh,
code.
you rock, man. That's incredible. Go and catch that, everybody. Again, if you are just hearing this and it's after Black Friday, the sale is still on just for Growcast members. So code Growcast boosted. And I'll be sure to drop that in the beginning too, so people hear that, man. Thank you for doing that, Nick. People are using your product. They're loving it. I want to see people grow any which way, but man, especially when someone's getting started and the guys in Living Soil, all of it, I recommend them Rooted Leaf. You do a great job, Nick. Thank you, man.
I appreciate it. I appreciate the support that everyone has shown us and given us. Definitely looking forward to making 2024 another kick-ass year.
I love it. Thank you so much, Nick. Rootedleaf.com, The Rooted Leaf on Instagram. Give him a follow. Stay tuned for more. We sure do appreciate Rooted Leaf and Nick. So stay tuned, listener. Don't touch that dial. That's all for now. Thank you for tuning in. This is Nick from Rooted Leaf and Jordan River signing off, saying be safe out there, everybody, and grow smarter. That's our show. Thank you so much for tuning in. I appreciate you all. Well, let's see. What do we have on the list? Of course, see everything we're doing at growcastpodcast.com. We got membership up there. Hundreds of hours of bonus content. If you like this show, you'll love membership. That's at growcastpodcast.com/membership. Brings you right there. You get resources and giveaways and members-only discounts, weekly live streams, archived content, plus the members-only Discord. I'll see you in there, everybody. We do have an event coming up in Illinois. We've got a gift drive that's December 2nd, and that's at the Bubble Hive in Loves Park, right up there in Rockford. Bubble Hive, December 2nd. It's a Growcast Giftmas gift drive. I'll see you all there at the Bubble Hive, 7 p.m. to 10 p.m. DM me for details. Thank you so much to the Midwest chapter. We'll see you all there. Going to give back this Christmas season. So I appreciate you all tuning in. I appreciate you members especially. Thank you so much for your support. We'll see you next time, everybody. Have a great day. Bye-bye.
Mitochondria are the powerhouses of the cells.